So for today's lesson, we're going to talk about solving systems of equations. Just make sure that you remember how to graph lines because that's very important. So on the first one, we graph the equation 1/2 x minus 1. We begin graphing at the y-intercept, which is -1, go up 1 over 2, and then connect the dots. You definitely want to use a ruler with this because when we start graphing more than one line on the same grid, you need to be as accurate as you can. So please, please, please use a ruler. Second equation, y-intercept is 0. Down 3 to the right 1, and there's your line. Okay, so systems of equations, all that a system of equations is we're trying to find the solution to two or more equations. Those equations might be linear, they might be quadratic. Usually we give you two linears and then a linear and a quadratic, but there can always be different ones that you can do. So when you solve systems of equations graphically, you need to make sure that both of your equations are in y equals mx plus b form. So we're dealing with lines for today. So make sure that you are in y equals mx plus b. Make sure that you graph each equation. You want to include enough points to see where those equations intersect. I will show you how to use the graphing calculator as well. But again, you need to be able to have enough points. You need to be able to use your straight edge to connect the dots to make a good line. The point that they intersect is always going to be an ordered pair. So you write your answer, your solution, as an ordered pair. The ordered pair is always an x comma y value. And then you can check the ordered pair in each equation. I'll show you how to do it, but I tend to not worry about doing that so much because, again, once you graph your lines and you even use a calculator to check, you're not going to actually have to show the check algebraically. So we need to be able to graph these lines. We need to color code them, label them, do something. This first line, y equals 3x minus 4, is already in slope-intercept form. You begin at -4, up 3 over 1, up 3 over 1, connect the dots, label your line. Second one is also in slope-intercept form, line 2. So here is where I'm going to begin at 0, and I'm going to go down 1 over 1, down 1 over 1. I'm going to graph that line, and I'm going to label this as well. It should be pretty clear that there's a point of intersection, and it's right there. That ordered pair, the point of intersection, the solution happens to be 1, -1. So this is your answer, the ordered pair. The graph is the work that got you that answer. The check really just means if you take each equation, you plug in the x for the x and the y for the y, you should get a true statement. So on number 1, if I say y equals 3 times x minus 4, does -1 equal 3 minus 4? And in fact, it does. If I take my second equation and I plug in the y for the y, does y equal -x? And -1 does equal 1, so it works. Let me show you on the graphing calculator. So what you would do on your calculator is you would go to your y equals, make sure your plots are not on. We're not doing statistical stuff. We're going to be graphing lines. In y1, you graph 3x minus 4. And you can hit graph, take a look at that line, and you can see that whoopsie. Oh boy. I don't know. I just moved something down. All right. Sorry about that. Let's see if that's good. Let me get this thing back up. Okay. Oh man, this is just not wanting to work for me. All right, let me just fix this calculator. I'm going to pause you for 1 second. Okay, sorry about that. We're back. So let me go back to y equals, and if I type in 3x minus 4, and I graph this line, that's the line that we did in blue. If I now go back to y equals, and I go to y2, and I type in -x, and I graph that line, there's the green line that we typed. The point of intersection you can see is right here. And in order to calculate that point of intersection, you will go to second trace. What are we calculating? Well, we're calculating the point of intersection, choice 5. Hit enter. Up here it asks you, or shows you, this is the first line that we typed in. And is it the first curve? Is this the first line that we typed in? All you do is you hit enter. Up top it talks about y2. Is that the y2 line that we typed in? Second curve, question mark, you hit enter. And then it says, well, should I guess your point of intersection? And you say, absolutely guess it. You hit enter again, and that's what we had as the answer, 1, -1. Okay, so always feel free to use your calculator to double check. This next one, both of these are in y equals form as well. It's going to be pretty hard to graph y equals 2x plus 10 because it goes off our grid. So you do the best that you can. You begin up at 10, 6, 7, 8, 9, 10. So this is not going to be perfect. You need to go up 2 and over 1, but we can't. So we're going to have to go down 2 to the left one, down 2 to the left one. We're really going to need our calculator for this because we're definitely way off the grid. Graph it and label it. The second one, we begin at positive 4, down 1 over 1, down 1 over 1. Graph that. Y equals negative x plus 4. No idea where this is going to intersect because it's way off my graph. So here's when I go to my calculator, go to y equals. I'm going to clear out what's in there already. And the first line is 2x plus 10. And then we should be able to see that graph right here. Looks like ours. Second line is negative x plus 4, negative x plus 4. And then when we see that graph, that looks like it. So it's somewhere in that second quadrant. So it's going to be negative positive. Let's see what it is. Second trace, intersect. I'm just going to hit enter 3 times. Enter once, enter twice. Give me a guess. Negative 2 comma 6. All right, so the work is the graphs, the solution, negative 2, 6. Okay, let's try this next one. X plus y equals 7. Well, the problem here is we're not into slope-intercept form. So if we subtract x from both sides, y equals negative x plus 7. Here's our 7. Go down 1 over 1, down 1 over 1. Graph your line. Label it. On the second one, I'm going to add y to both sides, and then I'm going to actually subtract 1 from both sides. So y equals 3x minus 1. Right, I brought the 1 this way, the y this way, but then I rewrote it for y equals. Begin here at negative 1, 1, 2, 3 over 1, 1, 2, 3 over 1. And it looks like my point of intersection happens to be right here. We're going to double check with the graph, but it's going to be in quadrant 1. Let's kind of go this way, and then I'm just going to go right to the calculator, clear these guys out, type in blue, negative x plus 7. We're going to type in green, which is 3x plus 1. I'm not even going to worry about looking at the graph. I'm just going to go right to second trace, choice 5. It's going to graph it for me because it has to. And then I'm going to hit enter, enter, enter. 1.5, 5.5. For some reason, that doesn't seem right. Let me go back up to this equation. Negative x plus 7, that's y. 3x minus 1. So one of the good things, too, is if you make a mistake in terms of your typing, you should be able to see where that graph should be. You could be able to tell very quickly if you did it correct or not. Let me try this again. Second trace, intersect. Enter, enter, enter. That looks more like it, 2, 5. So our solution here is 2, 5. Okay. There's a few more to do. I'm just going to do this one with you at number 4. If you graph both of these, you should notice something automatically about number 4, excuse me. So the first one, I'm going to begin at positive 1, down 2 over 1, graph the line, label it. Second one, I'm going to begin at negative 1, down 2 over 1, graph it and label it. And these lines don't intersect, they're parallel. We should have known that already because they've got the same slopes. So if the lines are parallel, they never intersect, they can't have any solutions. So when they ask you to find the solutions, parallel lines have no solutions. Intersecting lines have one, parallel lines have none. One more example. Look at number 6. Let me just drop this down a little bit. So this one, I'm going to have to subtract 2x from both sides and get negative 2x plus 8. Divide everything by 4. And I'm going to get y equals negative 1/2 x plus 2. Interesting. Same thing as that particular line. They're both the exact same line. So if I try to graph the first one, down 1 over 2, and draw it, and I graph the second one, begin up again at positive 1, down 1 over 2, you are graphing the exact same line. So it's not that there's no solution here. What's different from this is every single point on the first line is on the second line. So this answer becomes all solutions. So in graphing lines, your solutions could be 1 point, it could be no points, or it could be all points. And that's it.